first thing we're going to do is graph it. So here's 2x. And then 4x minus x squared. We should note that if we take the x out of that, that's x times 4 minus x. Should have intercepts when x is 0 and x is 4. We're going to get something like this. Is what that looks like. So we're looking at this region right here. And we need to figure out where those two functions intersect. So we'll do that by solving for x. We'll just get x squared. We add that to the other side, minus 2x equals 0. Looks like those intersect at x equals 0 and x equals 2. So we'll integrate from 0 to 2 the upper function, which is the parabolic one. 4x minus x squared, and then minus the linear function 2x. So this is the integral from 0 to 2 of 2x minus x squared, which is x squared minus x cubed over 3 from 0 to 2. And you plug in 0, that's just going to be 0. So all we need to worry about is plugging in 2. 4 minus 8 thirds. And that should be 12 thirds minus 8 thirds. It should be 4 thirds. Does that make sense?
Okay, thank you. Yeah.
All right. Anybody else? Other questions? Other questions? You all got all 45 of those multiple choice ones from last night, correct? Nobody's got any other questions. No issues with any of those 45 problems. I find that hard to believe. Yes, I could do number 88. Sure. Okay. Here is number 88. Number 88 is talking about a function f, which is got a second derivative that's negative, which tells us that the function is concave down. And then it tells us about a secant line and a tangent line to that function. So I'm going to draw a concave down function, secant line, and a tangent line. So here is capital S of x, the secant line. Here is capital T of x, the tangent line. Here is f of x, the actual function, which is concave down. We know that this is 3. We know that this is 5. We know that this is 4. And we're interested in the value of f, t, and s at 4.2. So we'll call this 4.2. Here is the value of s. The value of s at 4.2 has got to be less than the value of the function at 4.2, which has got to be less than the value of the tangent line at 4.2. So we need to have s is less than f is less than t of 4.2, which looks like that's choice C. And that will always be true for any function that is concave down. If you have a function that is concave up, the opposite is true. Right? The true value is less than the secant line, but more than the tangent line if you have a concave up function. Good or no? Does that make sense? No problem. Other questions? Other questions?
I guess, could you do 11 also from last week?
Sure.
All right, thank you.
Number 11. All right, number 11. We've got an integral from -1 to 1 of x squared minus x over x. Anytime you have just a single term in the denominator with some other expression, polynomial expression in the numerator, just divide x squared over x is x, and x over x is 1. So really this is just the integral from -1 to 1 of x minus 1. Yeah. So this becomes x squared over 2 minus x from -1 to 1. And that becomes a half minus 1 minus a half plus 1. So we've got -1/2 minus 3/2, which looks to be -2.
Okay. And then, sorry, there's a plane flying over my house, but whenever we have integrals, then we should always try to like simplify them like you did here, right?
Yep, if it's something that can simplify, yeah.
Okay, but then it's just that then when you have something like this, but then it's a derivative, you can't do that because you have to use, like, for example, quotient rule, right?
That is correct.
Okay.
Simplify the function itself before you try to take the derivative of it.
Mm-hmm.
But yeah, I mean, but if it's a quotient, if you can't simplify it beyond being a quotient, then you'd have to use the quotient rule.
Okay. Wait, so then in this case, could you have like, you wouldn't be able to simplify the x squared minus x over x first and then take the derivative, right? You would have to do the quotient, right? Then because
Okay, I could. If I want to take the derivative of x squared minus x over x, that's the same as the derivative of x minus 1.
okay.
Yeah, which is 1. I mean, if I did the quotient rule with this, if I used the quotient rule, end up with x times the derivative of x squared minus x, 2x minus 1, minus x squared minus x times the derivative of x, all over x squared. But then this just becomes 2x squared minus x squared plus x, when you distribute that minus sign through, all over x squared, which gives you 2x squared minus x squared. Negative x plus x is 0. You get x squared over x squared, which is 1.
Okay. But in this case, it'd be better to just like simplify first and then find the 1 instead of doing the quotient rule, right?
That's what I would do.
Okay. Okay. Thank you.
Mm-hmm. Questions, anybody? E6. Let's try this again. There we go. All right, 86. So we've got two functions, 4 cosine pi x over 4 and x minus 2 squared. Region R, shaded between them, is the base of the solid. Cross sections are isosceles right triangles with one leg in region R, perpendicular to the x-axis. So there is my isosceles right triangle. what is the area of a right triangle or of any triangle? It's 1/2 the base times the height, or 1/2 just this length across this region squared. So, yeah, base times height, base and height are the same since it's isosceles. What is the length of this? Well, it's just the distance from the upper function to the lower function. So L is just the cosine function, 4 cosine pi x over 4 minus x minus 2 squared. And so our integral should become 1/2 of that length squared dx from 0 to 2. And you'll put that into your calculator and have it evaluate that integral, and it comes out to be 1.775. Does that make sense? All right, next one is 83. All right, we're given an acceleration of a particle. We want to know at what value of t is the particle's velocity decreasing most rapidly. So we want to know when is so if the particle's velocity is decreasing at its fastest rate, that would be when is the acceleration at a minimum, because acceleration is the increase or decrease in velocity. We want acceleration at a minimum. So we need to take the derivative of the acceleration and see when that equals 0. So the derivative of the acceleration is t minus 8 times cosine t plus sine t, just using the product rule there. And so we want to know when is that equal to 0. And since we're talking about at a minimum, we want this derivative, this a prime value, to go from negative to positive on the interval from 0 to 8. So we would go in and we would graph this function. So x minus 8 cosine x plus sine x. And we're looking for when is this at a minimum. Well, it's at 1.42 and also at 7.045. And we'd also need to check our endpoints of 8 and of 0. And so we'll plug each of those values, 1.42, 7.045, 0, and 8 into our acceleration to see which one of those is the smallest. So if I plug in 0, that comes out to just be 0. If I plug in 8, that's going to come out to be 0. And then I plug in both of these to see which one is smaller. Clearly, it's not going to be that one. So if I plug in 1.42, the sign of 1.42 is positive, but 1.42 minus 8 is negative. So it's negative times a positive. So this one is going to be the smallest value. Does that make sense?
Yeah, thank you.
You're welcome. Other questions, anybody? So for number 13 here, we've got t greater than or equal to 1. We're given a position function. We want to know at what time t between 1 and 16 is the instantaneous velocity equal to the average velocity. The instantaneous velocity of the particle is just v of t. V of t is 1 over 2 root t minus 0. So just 1 over 2 root t. So we want to know when is that equal to average velocity. And what is the average velocity? Well, the average velocity is 1 over b minus a times the integral from a to b of the velocity function. So we want to know when does 1 over 2 root t equal 1/15 of the integral of v of t from 1 to 16. Well, what's the integral of v of t? The integral of v of t is p of t. So 1/15 of root t minus 2 from 1 to 16. So now we've got 1 over 2 root t is equal to 1/15 of 4 minus 2 minus 1 minus 2. That would be 2 minus -1, which is 3. So we've got 1 over 2 root t equals 3/15 or 1/5. We end up, if we cross multiply and then divide, we got root t equals 5/2. So t must be 25/4. Does that make sense?
Yeah.
Great. All right, and then we got 27. So we've got positive variables of p and c that are changing with respect to time. We know that p squared equals 20 minus c to the third. We want to know about dc dt. So how is c changing with respect to time? Well, that's a related rate question. So we're going to take the derivative of all of this with respect to t. That'll give us 2p dp dt equals 3 times 20 minus c squared times the derivative of 20 minus c, which is -1, dc dt. And they give us the values of c and the value of dp dt. They do not give us the value of p, which we'll deal with in a second. So 2, we'll deal with p in a second. dp dt is 41. 3, our c value is 15. So 20 minus 15 is 5. Cubed is 125. And we're looking for dc dt. We do need to find p, though, to plug in here. Well, we know that p squared equals 20 minus that 15 cubed. So we know that p squared equals 125, or that p, because it is positive, must be the positive square root of 125, which is 5 root 5. And then we're just going to divide by a 375 here. Yeah, well, negative 375. So we're going to end up with negative 82 root 5. And if I'm dividing the 5 by a 375, that ought to be a 75. equals our d, c, d, t.
Wait,
What-
isn't it squared, not cubed for the 20 minus 15 on the right?
Yeah, you're right. Sorry. Oh, no. Oh, geez. That's not the eraser. That'll affect that. What was it? I plugged in the 15, so that's a 25. So that's a 75 down here, which will cancel with the 5 to make it 50, which looks like choice D. Not sure why I cubed that when I clearly wrote a squared, but does that make sense though?
Yeah, thank you.
Yep. Other questions, anybody? Other questions? Yeah, give me a second. I'll put the answers back up here. No problem. Anybody have any other questions? Again. So this one we had grain in a silo, and it was a terrible silo because the grain spoiled so quickly. That makes sense. I remember all that now. So we want to approximate g prime of 3. So to approximate g prime of 3, we just find the average rate of change there between 1 and 5, because that surrounds 3. So 20.5 minus 15.1 over 5 minus 1, which ought to be 5.4 over 4, which is 1.35. And we had cubic feet per minute, and then differentiated with respect to t, so per minute. So we have cubic, we'll just write it this way, we have cubic feet per minute, or cubic feet per minute squared. And the meaning of that is that is the rate at which the grain is increasing. The rate at which the grain is being added is increasing. So it's the rate of change of the rate. So this is the increase in rate of GFT. Does that make sense?
Yeah.
Okay. For part B, we just wanted an integral to represent how much grain was added. That's just the integral of the rate from 0 to 80. So then you wanted to approximate that using a right-Riemann sum. Since the subintervals are all different, 1, 4, 1, 2, they're not equal subintervals, we have to break it down into each one separately. So the first one is from 6 to 8. So that's 2 times the rightmost part of it, 2 times 22.7, plus 1 from the distance from 5 to 6, times 18.3, plus 4 times the height at 20.5, plus 1 times 15.1. And I don't know what that came out to be. Somebody remind me what that came out to be.
I got 160.8.
That sounds right. I remember that number vaguely from yesterday. Yep. So that was part B. Good with that?
Yeah.
Part C, we've got the grain is spoiling at this rate. We want to know, using our amount that was in the silo from part B, approximate how much unspoiled grain is in the silo at 8. So that ought to be the amount of grain put in the silo plus the initial amount of grain in the silo, which is 0, minus the integral from 0 to 8 of W of T dt, which is the number of cubic feet of grain that spoils. And that number came out to be, I want to say, it was like 60 something, 64 point something maybe, or I don't remember offhand.
Yeah, I got 61.749.
That sounds good to me. That's probably right. It was in the 60s for sure. So, and then part D, we want to know if the amount of unspoiled grain is increasing or decreasing at T equals 6. Well, the rate at which it's increasing is G of 6. The rate at which it's spoiling is W of 6. So just look for the sign of G of 6 minus W of 6. G of 6 minus W of 6 came out to be a positive number, so the amount of unspoiled grain is increasing. Good or no?
Yeah, good.
All right. And then the snail problem. First, we were looking for the snail's acceleration at 5. So that was just v prime of 5, which I don't know. I feel like it was like 0.5 something or another.
Yeah, around there.
0.5 something, something, something. Make sure you round to 3 decimals. But that part should have been pretty easy, right? Just the derivative of velocity is your acceleration.
Yeah.
Hold on 1 second here. Sorry about that. My kid was texting me because he wants to play games on his phone, and I had to tell him that when you get zeros on your math assignments, you don't get to touch your phone. We want the displacement of the snail over the interval from 0 to 15 minutes. So displacement is just the integral of velocity. Integral from 0 to 15 of v of t dt, which came out to be, what did that come out to be? I don't remember what that was, 18 point something, I think, maybe. I could be wrong.
I got 76.043.
That sounds good. Sure. I don't know. I just made up 18. I don't really remember. But that sounds like a good number. And then we want its instantaneous velocity to equal its average velocity. So the instantaneous velocity is this, v of t. And we want that to equal 1 over 15 minus 0 times the integral from 0 to 15 of a dt. So that's the instantaneous velocity. That's the average velocity. And the integral from 0 to 15 of v of t was 76. We divide that by the 15. And what does that give us? 6 point something, 5 point something, 5 point something, right?
Yeah.
5 point something. And so then you graph that v of t, you graph this function, and then you graph y equals 5 point whatever that number was. And you look for where they intersect. And where did they intersect? What did you get?
I didn't get this far.
Okay. All right. Well, then let's graph this. So let's see here. Let me open up Desmos. So 76.043 divided by 15. And we'll make that y equals. And then we had, what was it was 1.4 natural log of 1 plus x squared.
Yeah.
And it looks like those intersect at 6.031. I didn't share the decimal. I did share the decimals. Okay, yeah. So that's all. Does that make sense? That's your y equals 5 point whatever number, and then you set that equal to 1.4 natural log of 1 plus x squared to see where they intersect.
Yeah, makes sense.
Perfect. Cool. And then part D, we've got an ant that arrives at the snail's starting position at t equals 12 and follows the snail's path. It has an acceleration, so the acceleration of the ant is 2. And we are looking for the ant's velocity. So first off, the velocity of the ant ought to be the integral of 2, which is 2t, plus some constant. We need to find that constant, though. And so in order to find that constant, we're going to have to find the distance, the total distance that this ant traveled, and find its equation. So that should be t squared plus that constant times t plus some other constant. Now, we know that the position of the ant at t equals 0 needs to be 0. Position of the ant at 0 is 0 because that's what it says. It started at the place where the at t equals 12, that ant was at the same place, right? And so this constant ends up being 0. So we end up with t squared plus ct, and we want that total distance when t is 12, or sorry, when t is 15 to be 76.043, because that's how far that ant goes. In that time period. Oh, sorry. This is our integral from 12 to 15. Not. It's gone 76.043 at t equals 15, but this is an integral from 12 to 15 because that is how far the ant traveled from t equals 12 to t equals 15. And so we use that to solve for c. Does that make sense, that setup, or no?
Yeah, that makes sense.
Okay, so then we use that to solve for c, which, I don't know, that's 76.043 minus 81 is negative, I don't know, it comes out to be negative 1 point something or another. I don't know if you had to, I guess I can do it on my calculator here. 76.043 minus the 81 divided by 3 is negative, so that constant is negative 1.6523. And we want to know what is the ant's velocity at t equals 12. So then we'll do 2 times 12 minus 1.6523, which comes out to be 22.348. Does that make sense?
Yeah, that makes sense.
Anybody else? Any other questions? Any other questions?